I'm back to recording. Any other questions about exam 2? So exam 2 is one of your midterms. Yeah. It's actually a misnomer on my end, huh? Why did I call them midterms if there's like 3 of them? It's not midterm. They happen farther out than midterm. So yeah, that's my bad. Any other questions? Any other questions? Okay. I think I spent long enough on this. If there are any other questions that pop up between now and the end of class, let me know. I'll try to answer them. That's all I got for now. So let me go to this thing. Okay, so today, what I wanted to do, I've already discussed exam and the practice exam. What I want to do today is finish up everything basically for your exam 2. Excuse me. So we left off at section 5.3. I want to do section 5.4 today so that you guys can have everything for exam 2 ready and good to go. And if possible, start section 6.1. Section 6.1, not time critical since this is not on the exam. We can push this off to next Monday if needed. Yeah, cool. Any questions? Any questions? Okay. So where we left off on 5.3 was, I believe we were learning about the last 3 big ones. Last 3 big trig functions. Let this thing load a little bit. So let me do a quick recap of section 5.3 so that we know what the hell we're doing. So from the very get-go, all right, my computer is not being nice today, you guys. It's throwing a fit. There we go. Okay. So from the very get-go, we knew about these 3 right here. We knew about sine, cosine, and tangent, okay? They were the opposite of over a hypotenuse if you had a triangle, and if you had it on a unit circle, they were the x divided by the radius of the circle, whatever that might be, okay? The last 3 were those 3. Cosecant, secant, and cotangent, okay? They sort of matched up, okay? Cosecant is 1 over sine, which is the flip of this thing right here, right? Secant is 1 over cosine, which is the flip of that thing right there. And then tangent is, or sorry, cotangent is 1 over tangent, which is the flip of that bad boy right there, okay? So we practice with 1, okay? And just as usual, right? If you have coordinates, right? The cosine was the x and the sine was the y. So we were able to do these 3 just from the point themselves, right? And then we had to do these 3 over here using the formulas from above, okay? So I gave you guys some practicums here to do. I think we got through just one of the practices. We never got through the other one. So let's finish the other ones off really quick. So let me do number 3 really quick. Okay. So automatically, right, sine of the angle theta is that one. So 2 root 5 over 5. And then cosine of that is root 5 over 5. So at this point is where we use these definitions right here, here, and here to do the rest of these. Okay. So secant of theta is going to be 1 over cosine, which is root 5. Actually, zoom into this. I'm trying to erase something, and now it doesn't want to do it. There we go. 1 over the square root of 5 over 5, which is 5 divided by the square root of 5, which is root 5, if you do the simplification for it. Got it? Cosecant of the angle theta is 1 over sine. So it's going to be 1 over 2 square root of 5 over 5, which is 5 over 2 square root of 5. So this is where you get to multiply times root 5 times root 5. The reason why is because of this right here. These two together multiply together, and they make the 5. So this is going to be 5 root 5 over 2 times 5. This is where we have the 5's cancel out. So this becomes root 5 over 2. Okay. Tangent. This thing now wants to act up. Sorry, you guys, this thing takes forever. There we go. So tangent of an angle theta is equal to the sine over the cosine, which is these two up here. So it's going to be 2 root 5 over 5 divided by root 5 over 5. Okay, you guys notice you have two things here that are exactly equivalent. So those two cancel, you get left with 2. Okay, and lastly, cotangent of theta is basically the one for tangent, but flipped. So it's going to be root 5 over 5 divided by 2 root 5 over 5. These two things are, as I flipped, right? That cancels that. 1/2. Are we doing all right? Tell me to stop if you need it. Okay. Okay, so um, this is the point where we get to really see the beauty and the usefulness of our unit circle. Okay, the way that we use its cyclical properties to get us answers to way bigger numbers. Okay, so if you think about it, right, there are, how many angles is that? There are 1, 2, 3, 4 times 4. So there are 16 big angles, right? And there are 6 trig functions for each one, right? So for just a unit circle, right, that's a lot. I'm not going to do the math. At least not for that. There are a lot of bits and pieces that that you can compile just from looking at the unit circle, right? But I think, as you guys have noticed, because of the reference angles, right, we only need things in that first quadrant. In particular, if we know the nice angles, right, we only need to know 1, 2, 3, 4, 5. We only need to know 5 of them, really, okay? And the reason why is because the unit circle, and any angle for that matter, sort of repeats itself after a specific number of times, right? So we saw this when we had to do, so if you guys remember, right, if I said, what is it? Let's say we needed 405 degrees, right? That was the same thing as going a whole 360 degrees plus another 45. So if we needed to reference anything, we just go to 45 degrees. We didn't have to actually go to 405 degrees, right? So same thing happens over the entire unit circle, okay? So specifically, I'm going to use the reference angles to find the 6 trig functions of 5 pi over 6, okay? So we know that 5 pi over 6, I'm going to go ahead and draw this thing out here. So 5 pi over 6 is something over here, right? So here's my, I tried half a unit circle. Right? Whoops, wrong direction. Negative 5 pi over 6, so that is about right here. Okay? And technically, right, so we know that the reference angle for this is pi over 6. It's in there, right? But we know that both the sine and the cosine are got to be negative, right? So now what we need is that coordinate, right? That coordinate for pi over 6, this is where we go to our handy dandy unit circle. If you guys have it handy, this is going to be root 3 over 2, 1/2. And that's basically all we need, because we know what cosine theta is and sine theta is from just that point. So once this is done, we are off to the races, because we know where this lives and we know the reference points for them. So sine of theta, whoops, how about we do it sine of negative 5 pi over 6. That is going to be negative root 3 over 2. Since we know it lives down here, right, we know that the cosine would have to be negative, right? 1/2. I apologize for that one. The weekend was just not long enough, man. It wasn't. Okay. Cosine of minus 5 pi over 6, that is root 3 over 2. Tangent of minus 5 pi over 6 is sine divided by cosine. So 1/2 divided by root 3 over 2. And if you do this right, you'll get root 3 divided by 3. Stop me if you need me. Stop me if you need me.
So pi
Yeah.
or 5 pi over 6, that's originally like on the upper right. Is it on the lower right because it's negative?
Right. So remember when you do negative, you go, what is that, clockwise?
Mm-hmm.
Right? So our point, our actual value is down here,
Okay.
right? But like I said, we're using our reference angle. So we know that this point is equivalent to this point, right? The only difference is our cosine and our sines in this case are negative because they live way down here.
Oh, okay. Okay, I get it.
Got it?
Yeah.
Okay. So let me do the last three. Cosecant of minus 5 pi over 6 is equal to 1 over sine, which is 1/2, that's 2. Secant of minus 5 pi over 6 is 1 over square root of 3 divided by 2. And that reduces to 2 square root of 3 divided by 3. And then lastly, tangent of minus 5 pi over 6 is equal to root 3, whoops, sorry, 1 over tangent right here, right? 3, root 3 divided by 3, which is equal to, you do this right, root 3. And those are your 3 values. Okay, so I want you guys to practice with this a little bit. So I'm giving you guys a couple values here, okay? There is one change here. So for this one, I didn't mean to put 130, negative 135 degrees. Okay? So if you guys have your unit circle at the ready, you're going to be using this a lot. I'm gonna have you guys try them out. I'm gonna give you guys some. I'm gonna put you guys in your groups for a little bit, and I want you guys to try to find the six trig functions for each one of these angles. Okay, and go. Oh wait, not yet. All right, and go. Good, bad, me.
We got pi over 2. That means it's the are we doing the the reference, so it's 0 slash -1,
What do you mean slash -1?
or the two numbers, the
You
X and Y, the X and Y.
So for pi
Or
over 2,
my
what is x and what is y?
0 and 1.
Right.
Are you doing the? Oh no. Okay, never mind. I thought we were finding the reference.
Mm-mm.
Never mind. Okay.
Since this one's already in that first quadrant,
Mm-hmm.
you're free and clear. You don't have to do any reference finding in this case.
Okay.
Got it?
Yes.
Okay.
Wait.
Mm-hmm.
So it says the third one is sine over.
Tangent, right? Tangent is sine over cosine.
Yeah, sine over cosine, and the cosine is 0, so the whole thing's just going to be 0.
No,
Really?
no. So you have 1 divided by 0, right?
Yeah.
What's anything divided by 0?
So wouldn't that be undefined?
That is undefined, exactly. So
Oh, okay.
you guys have the very first one where it is undefined.
Okay.
Got it?
Okay. Okay.
That's why we should do our work outside. I'll go to Costco, see what they have a big table. All right, I'm gonna bug another group.
Oh.
Let's see these
This
guys.
online learning sucks.
Online learning sucks. I know. The only thing we got though.
We could get a big table, just say 6 feet away. And
We
don't
need
spit
an
on each other.
auditorium.
Yeah.
Yeah.
It's all right. It is what it
Yeah.
is.
Yeah, it is what it is. You know, I bet you that in class we had so many people like drop and not show up on a regular basis. We could have been 6 feet away from each other in class.
Our class
But-
did get really small.
Yeah. I don't know why, but yeah. That's a question for another day. All right, I'm gonna go mess with another group.
All right.
Okay.
Okay. What did you guys get?
I'm still working on it because I accidentally printed out the wrong paper.
Okay. Maybe I should give people a little longer.
Mm-hmm.
Okay, let me go mess with another group really quick.
Okay.
Thumbs up, thumbs down. Meh.
Not sure yet.
Not sure yet, huh?
We're just wondering if we have to use the reference angle for these.
Yes. So for yours, you do have to do a reference angle.
Okay.
Or you can, so the other one is you can actually use the values themselves. That's the power of the unit circle. So for yours, you can use the reference angle, or if you just have sort of like the unit circle out in front of you, you can just look at whatever 135 is, right? And then give me the values for them.
But if we don't use a reference angle, it would be a negative for cosine
So where should the reference angle live?
in the first quadrant.
In the first quadrant.
So we have
So
to
the-
use a reference angle.
Huh?
So we have to use a reference angle?
You don't have to.
So if we don't, would it still be negative or no?
Right, which one would be negative, the sine or the cosine?
The cosine.
Exactly.
So would we get, that's what I don't get, would we get different answers if we don't use the reference angle?
Mm-mm.
Because if we use it, it would just be, the cosine would be square root 2 over 2. And if we don't use it, it would be negative square root of 2 over 2.
Well, 135 lives where?
In the second quadrant?
Right, so the reference angle that you would use is the one for 45 degrees, right?
Mhm.
But since 135 lives in the second quadrant, you know that your cosines are going to be negative no matter what.
Oh, okay. So we could
you're
still,
go ahead.
so we could still use a reference angle. We just have to remember to put the negative because it's in the second quadrant.
Exactly.
Okay, got it.
Yeah?
Yeah.
Cool. Cool. Whew. All right, I got one more group to bug. Okay?
All right.
I'll see you guys back over there in a second. You guys. Thumbs up, thumbs down. Have you guys all gone crazy because of pre-cal and not because of Corona?
No, I haven't. Now, do you think chapter 5 is easier than chapter 4?
Hells to the yeah, it is. So many ways to get all of this stuff right if you know how to use your unit circle.
Now, I haven't done the homework for chapter 5, but I've gone through the lectures. Will the videos also tell you how to also do the things with that circle thing?
Yes.
Okay, so I don't have to worry about that. It'll show me on the videos.
Yup.
Okay, perfect. 'Cause I got like kind of the gist of what to do with it. I just don't know exactly how to do it. I've been working on chapter 4.1 through 4.7 a lot. I was having trouble
Right.
with 4.6, but I finally figured it out, so I feel comfortable with it now. I think 4.5, 4.1 through 4.5 wasn't too bad. 4.6 gave me a little bit of trouble. 4.7 I think is actually not that bad at all. I think the test is actually, I feel like it's going to be easier than the last test, actually.
That's the hope.
That is the hope. Yes, exactly. That is the
Yeah.
hope. So the next
That
test
is the
rolls
hope.
around. We'll have to see what happens.
Yeah. Yeah. So, I mean, chapter 5 is really sort of like basic stuff, which is good that you guys have it on the test because if it's basic stuff, it's easy to grasp. That's sort of like freebie points, right?
Exactly.
So, yeah. So for this stuff, you guys good?
Yeah.
Thumbs up, thumbs down, me?
Thumbs up.
Thumbs up. Okay. All right. I think it's time to bring you guys all back. So I never asked people, what did people do over weekend?
Not that much, honestly. Mostly just homework and work.
Oh yeah, that's right. You guys still had work. Well, I did too. Skate. As in like ice skate or just like rollerblade or skateboarding. Yeah, skateboarding, bro. Okay. That sounds cool. I've been wanting to take my bike out for a ride. I don't have to spend time like getting ready to go to work. I actually realize how much time I lose in my day from going to work. and getting ready to go to work.
I bet, honestly.
Like, and it's the same thing for you guys, right? How much time do you guys actually waste in getting ready to come to school? Like, if you think about it now, right? I'm pretty sure half of you guys aren't wearing pants because you're still in bed.
I'm not wearing pants because I'm fucking lazy.
Like, it just makes me
You're
think.
right, though.
Yeah,
How
Like,
long does it take someone to get ready to go to school?
yeah. For you guys, it's how long it takes for you to get. So for me, it takes me like an entire hour just to get ready, right? 10 minutes max. Plus, like, and this means like get ready completely. Like, make sure I have my stuff to go to school. Make sure I have my lunch. It's packed. Make sure I smell good. Make sure the deodorant's on. Everything, right?
No one likes a stinky
then-
teacher.
Huh?
No one likes a stinky teacher.
Nobody likes a stinky teacher. Right. plus an extra 25 minutes that I have to sit in my car to drive to work. An hour and a half. From alarm going off to me being at school. Plus another half an hour to drive back. That's 2 hours I'm gaining here. I'm gaining 2 hours worth of my life.
You gotta think it's true. Like when we got back, we didn't go grocery shopping because we didn't want to go to the stores, so we just did everything online. So you know how
Right.
easy it was to get ready to go pick up our groceries.
Yeah.
Like before, my wife had to take a shower, do her hair, get the kid ready, makeup, and then walk around the grocery store. Now it says it's ready at 11 o'clock. We just get in the
Go
car
pick it
and
up, come
drive. Like 5 minutes.
Yeah.
So
I don't know. That's one of the things I realized over break or over the weekend, that I'm saving so much time now. Like,
there's so much.
that's probably where my days have gone, right? So
We have so
yeah.
much more time for activities.
Yeah. All right. Back to this thing. Let's do. Aha. This is actually a good one. I'm gonna do these two. The 135 and the negative 135. So if we look at our unit circle, right, and I'm actually going to use the box before it. Let's see, into shape. It didn't actually do it. Oh, come on. Okay. So for 135, we know that it lives somewhere over here, right? And if we use our reference angle is 45 degrees, right? So then that means we can look at the equivalent 45 degrees that's over here and use that to make our decisions, right? We just have to keep in mind that 135 is in that second quadrant, right? So sine of 135 degrees. So we know that this point right here, if we look at our unit circle, that is square root of 2 over 2, comma square root of 2 over 2. Now, we know that this is in the second quadrant, so that means that my x's will be negative. So it's going to be negative root 2 over 2, comma root 2 over 2. Whoa. There we go. And we have our 2 points. Or sorry, we have the 1 point. So from here, we can solve everything we need. So sine is still root 2 over 2. Cosine of 135 is negative root 2 over 2. Tangent of 135 is sine divided by our cosine. So it's going to be root 2 over 2 divided by negative root 2 over 2. and that becomes -1. Okay. Cosecant of 135 degrees is 1 over sine. So that's going to be 1 over root 2 over 2. And if you do this right, square root of 2. Secant of 135 degrees is 1 over cosine, which is negative root 2 over 2. And that becomes negative square root of 2 if you do the math right. Okay, and then last, cotangent of 135 is 1 over tangent, which is 1 over -1, -1. There you are. There's all 6. Whoa. It's the wrong one. How we doing? Yay? Nay?
Okay.
Okay. Okay. Like I said, stop me. Stop me if you need it. Okay. So it's a good thing that I had -135 on here. So I'm going to do the exact same thing. I'm going to try to draw it. Okay. -135 is somewhere over here. We have to go negative. Right? The angle here is 45 degrees. So that means our corresponding reference angle that we're going to be using is the 45 degrees here. We know from the previous problem that this is yep. So I knew it was going to happen. My notes just crashed on me. So give me a second, let it open up again. There we go. And let's see. All right. And we're back. Okay, like I said, we have the similar 44, similar reference angle here. The points being root 2 over 2, comma root 2 over 2. But we are in quadrant 3. And in there, both sine and cosine are negative. So we just need to make sure that the sine and the cosine that we write down are negative. So sine of -135 degrees is negative root 2 over 2. Cosine of -135 degrees is negative root 2 over 2. A tangent of -135 degrees is negative root 2 over 2 divided by negative root 2 over 2. Actually, I'm going to put both of those. One. It's divided by the same stuff, right? Cosecant of -135 degrees is 1 over sine. So 1 over negative root 2 over 2, which is negative root 2. I'm going to be sounding really repetitive here. Secant of negative 135 is 1 over negative root 2 over 2, negative root 2, and then tangent 135 is equal to 1 over, sorry, cotangent is 1 over 1, which is tangent, which is 1. We have all 6. 1, 2, 3, 4, 5, 6.
I was absent last time, so I have a question about how do you find like the prices for sine, like the root of 2 over 2. This is like something standard.
Yes. So, like I said, let me go back to unit. Let me, there's somebody in the chat box for number 3. I thought the points were root 3 of, yes, they are. So, for number 3, you're talking about this one, right?
Yeah.
No, this is for Miguel. Yeah. So, this drawing that I did right here, that is actually for the problem. That's actually for negative 135. So I didn't do number 3. Yeah. So sorry. I was using the box for number 3, so I can draw the picture for number 4, just so that people don't get confused. And what was your question again, Mohammed, again?
Yeah, just about the numbers.
Yeah,
like
the standardizations. So if we go back to 5.2, remember I gave you guys this big packet? So like I said, this is supposed to be a trifold. It actually folds up into 3, okay? I give you guys a good version of the unit circle, right?
Yeah.
And 135 is right here, right? Pi over 2 is right there. So you can use those values off the top and you don't have to compute them again. So that's the power behind the unit circle, that the values for any angle, positive or negative, have to fall somewhere in here, right? And that's the reason why we have those things called reference angles. We can go back to the reference angle that fits between 0 and 2 pi for it, and we just need to know where it lives. Does it live in the first, second, third, or fourth quadrant? And then change the signs depending on where it lands.
Okay.
Right?
Yeah.
Did that answer your question?
Yeah.
Yeah?
Yeah, thank you.
Okay. Let's go back to 5.3. Okay. So there are certain, you guys remember what odd and even properties were? So an even function was if you plugged in negative x into a function, you got f of x back. Okay, and an odd function was if you plugged in negative x, you got negative the function back. Okay, so we have some even and odd functions for cosine and sine. Okay, and they're all sort of semi-related. Okay, and what I want to cover here is why. Why is cosine and secant even, and then the rest are odd? Okay, the way that we do that is straight out by using the unit circle. So how about we do, I'm gonna draw my unit circle again. I'm trying. Try one more time. There we go. Okay. So as you guys know, we start at 0 degrees, right? Okay, and what we're gonna do is we're gonna go up and down the same degree theta, okay? So this is going to be some value A and B, correct? Okay. What can you guys tell me about this point down here? So which one's positive and which one is negative?
The first one's positive and the second one's negative.
Right. So the A is going to remain positive, right? And the B, right, the B is going to be negative, right? Now what we're going to do is we're going to look at the direction that we went. So that was going to be a positive angle theta. Make sense?
Yeah.
And this one was going to be a negative angle theta. Right? And it turns out, just how I said, right? So when we look at coordinates, right? Cosine of theta is the x, and then sine of theta is the y, right? This in itself proves why we have even and odd functions. So if we go a negative angle, right, the cosines remain the same. Hence the reason why we have a cosine of negative theta. If we go cosine of a negative angle, right, that is equivalent to cosine of the positive angle. So and this proves even. Right? And then likewise, let's say we had sine of a negative angle, right? From our drawing, we know that is equal to negative sine of that positive angle, right? Because sine is referring to that y value, right? If we go negative, that's equivalent to this positive y value, but negative. Makes sense? And that right there proves odd. Okay, and these two are the big ones. Because from there on, we get the rest. Okay, so for example, secant of theta is 1 over cosine of theta. So secant of negative theta is equal to 1 over cosine of negative theta. Because of this very first one here, we know that's positive theta. 1 over cosine of theta, which is just secant of theta. So secant is even. So secant of negative theta is equal to secant of theta. And hence the reason why are we good with this stuff? All this is to get you guys practicing more and more with stuff. Okay? Okay, even in odd stuff, okay? Just to get you guys some practice of how useful this stuff is. Tangent of 45 degrees is the sine over the cosine, which is root 2. Let me give myself a little bit more room, is root 2 over 2 divided by root 2 over 2, okay, which is 1, okay? Here's where the usefulness in the odd and evenness of our functions really help out. Tangent of negative 45 degrees. Since we know tangent is an odd function, we know that this is equivalent to negative tangent of 45 degrees. Since we know tangent of 45 degrees is 1 from above, this is going to be equal to negative 1. So we have our two answers. Okay. Moving on, moving on. Secant. Secant of 5 pi over 6. Let me actually write those right. 5 pi over 6. So we look at our, this is 1 over cosine of theta. Whoops, sorry. 5 pi over 6. We have an angle to play with, right? This is going to be equivalent to 1 over root 3 over 2 negative, right? So then this is equivalent to 2 root 3 over 3. Okay, now secant of negative 5 pi over 6. We know that secant is even from up here. Okay, so that means we don't care about that negative that's in there. This is the same thing as secant of 5 pi over 6. We found that out already. 2 root 3. Oh, negative. Negative. How are we feeling with this stuff? Like I said, stop me if you need me. Okay. So the stuff before is really useful in finding values if you know how to use your unit circle right. I am hoping that all of you guys are going to be doing some really, really difficult STEM stuff. And what I mean is like by going into your biologies, going into your chemistries, going into your physicses, going into your engineerings, okay? And more often than not, there's going to be things that you're going to need to reduce because they're going to need angles, okay? And we're going to start with those now, okay? So what I mean is there's going to be times, this especially happens a lot in engineering and in physics, where you have tremendously nasty, convoluted trigonometric functions that you're going to have to be dealing with, right? And the very first thing you'd want to do is to simplify, okay? So maybe you can get something to go away, right? Or maybe you can clean it up enough to make it look a little neater, right? And that's what we're going to do today. This is going to be the very beginning of it all. It's only going to be using just the identities that we've been using, okay? Once we get farther into chapter 6, you guys are going to be seeing some really good heavy stuff, okay? But for now, we're going to just take it nice and light, okay? For now, you can use any identities that you that we've covered up to now, okay? So that means using the Pythagorean identity. Let me write that one down really quick. So the Pythagorean identity is the sine squared of theta plus cosine squared of theta is equal to 1, okay? As well as any of the other ones that we just have introduced at the very beginning of this section. So, for example, tangent of any angle theta is equal to sine of that angle divided by cosine of that angle. We know secant of an angle is 1 over cosine of an angle, right? Dot, 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 dot. Okay. You can use any one of those. Any one. Whoa. It did it again, you guys. It did it again. Okay, we're back. Secant of theta is equal to 1 over cosine theta. Okay, so you can use any one of these. You can use any one of the identities that we've used up until now. Later, we'll get into some really good ones and some more advanced identities that we can play around with. For now, I'm not going to give you guys anything much more difficult than this. Okay, and you can use whatever identity you want that we've used up until now to simplify or to prove another identity, okay? So for example, we have for A, simplify the identity secant t divided by tangent t, right? The best thing you can do is switch it, for now, is to switch everything back to their bases of sines and cosines, okay? So for example, secant, right? So secant of t over tangent of t, secant is 1 over cosine. And tangent, right, is sine of t divided by cosine of t. Okay? So now we have this going on is equal to 1 over cosine of t divided by sine of t over cosine of t. And in order to do the division of fractions, I get to flip the second one and make it into a multiplication, right? So 1 over cosine of t times cosine of t over sine of t. We have a cosine on the bottom and on the top, so those can go away. And we're left with 1 over sine of t, which is equal to cosecant of t. And we are done. So notice, for now, I know this sounds probably like, well, what am I going to use this for? Believe me, you're going to see this in physics all the time, okay? In particular, right, you may not like writing secant over tangent every time, right? So you reduce it down to cosecant. And you can play around with that, okay? This one is a little easier. So tangent is sine of t over cosine of t times cosine of t, right? And I'm going to do this because it's math. I can do that. Same thing, right? Cosines cancel out. I have one on top and one on bottom is equal to sine of t. So instead of writing this, I can now write this. Got it? Okay, so I've got a couple here for you guys to practice. I'm going to do the breakout into groups again. So your group number tells you what problems to do. Try to reduce it to one specific trigonometric function. Okay? I'm going to give you guys maybe about 10 minutes to work on this. I'm going to put you in your breakout rooms, and I'll bug you guys every once in a while. Okay? All right. Hunter, Bryce, Ignacio,
I got sine over cosine. for
which
the fourth
is?
time. Oh, we were actually supposed to solve it, not just do like simplify it down.
Well, yeah, simplify it down, but what's sine over cosine?
Oh, tangent.
Done. If you think so. Are you sure you're good?
Yeah, because tangent is sine over cosine.
You're close. What happened to the top part?
The top part just cross canceled kind of.
Right. So what did you get left
'Cause it
on top?
Oh, a 1. Also be 1 over sine over cosine, which would be basically 1 over tangent, which is what the last one, COT.
Cotangent. Right. Yeah.
Oh, I forgot about the 1.
Yeah, don't forget about the 1. Don't forget about the 1.
I will make note of that.
Yeah. Okay. You guys are good. I'm gonna go bug somebody else. You guys.
Hello.
Hello. Good, bad, me?
I don't know.
I don't know.
I don't know if I got. I don't know if I did it correctly, but I
Well,
got.
what'd you get?
I got 1.
Yep.
Is it really? Okay.
Yeah.
Okay.
Like, no kidding. It's 1. The most fanciest way, you guys all probably know how to write the number 1.
Because I simplified everything, or
Yeah.
did the layman's term of everything. Then I just crossed out everything, and the thing that was left was 1. So.
Yep.
Okay.
That's the point.
Okay.
Okay. I'm gonna go bug somebody else.
Okay.
You guys. Wait, is there anybody in here? Nobody's in here. I am talking to myself. Awesome. Okay. You guys. Yay, nay, nah? I broke everybody.
I actually got, I think I'm doing okay. I got,
What'd you get? So you guys didn't have to do number 2.
yeah.
What'd you get?
So I got cotangent.
Yup.
How would I say that? Cotangent
Theta.
theta? Oh, that's it?
Yeah.
Okay.
Yeah, that's it. Cool. Okay. Okay. I'm gonna call you guys back now. It seems like you guys got this pretty fast.
Yeah, I got it.
Yeah. Seems like everybody got this section pretty solid, which is good. Don't get me wrong. Okay. 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 After this, I think we're gonna go ahead and go to our break. We'll do that till maybe about 11:50, and hopefully we can get through 5-4 before the end of the day. Okay. So I only want to do 2 of these. I'm gonna do these 2. Okay, so like I mentioned, right, we just want to turn everything possible back into sines and cosines. It's the easiest thing we can do for now, right? And then simplify it using our other methods, right? So we have sine of x times secant, right? Which is 1 over cosine of x divided by tangent of x, right? Our sine of x, we can easily do sine of x divided by 1. So anything we can put over 1 because that's still true, right? We can multiply across. We get sine of x over cosine of x divided by tangent of x. Sine over cosine is tangent of x over tangent of x, 1. Simple enough, right? Okay, cotangent is cosine of theta over sine of theta times secant, which is 1 over cosine of theta all over cosecant of theta. Okay, we have cosine on top and on bottom. They can go away. So we get left with 1 over sine theta divided by cosecant theta. 1 over sine of theta, that is cosecant of theta over cosecant of theta is equal to 1. So all of this reduces to 1, hence the reason of its utility and why it happens so much in physics and your higher level natural sciences and physical sciences. You don't want to mess with this. I'd like to mess with 1. Got it? Okay. It's already 11:20 something. So what I want to do is I'm going to go ahead and let you guys go for some group work problems, which are below. Okay. I'm going to let you guys do this for about 20 minutes. Within those 20 minutes, go ahead, take your breaks. I'll be online to allow you guys to ask me questions and stuff. Besides that, you're off on your own.
You'll be also posting this lecture on YouTube as well, right?
Of course I am. Yep.
Nice.
I posted up all the ones for last week, right?
Yeah, I've been watching all of them over and over again, so that's why
Okay.
I asked, because they're honestly really helpful. I really like them, actually.
Boom. Okay. I like it then. So nothing else fun over the weekend for anybody? Man, I think it's getting to people now. Like, what is it? We're week 4 now into quarantine. So it's sort of like it's going to be another month or two. Yeah, I know, another month or two. Like the first week, everybody was like, "Yeah, we get to stay at home." Woo! Then second week came around, and we're like, "Okay, this is pretty cool, right?" Third week came around, was like, "Okay, now I'm beginning to lose my mind." Right, and then now fourth week he's like, okay, this is not cute anymore. We need to stop. Oh man, Miss going out to yeah. I mean, technically, you still can go out to eat. You just have to bring it home and eat it there. Yeah, yes, yes. Sushi we haven't had in a while. We've been limited to the number or the food that we can eat. We're pretty limited to the food that we can eat. We can only eat what, burgers, pizza, whatever has takeout. Sushi is not good for takeout. Give me a second. I can cook anything I want. Yes, that is true. However, it gets boring eating the same thing over and over and over again. And I don't think I can make food for one or food for two, right? I have to make food enough to last me. And this is maybe a bad habit. I need to make myself enough food to last me like 3 or 4 days. Which in itself is not good. Sort of like, I don't know, you get bored of your own cooking. Such a nice day outside.
Just for confirmation again, the test is on 4.1 through 5.4, right?
Yep. That's why I want to get through 5.4 by today. I think we can do it.
I think we could probably, we have an hour, so I think we could probably do it as well.
You can do it, yeah. How long is, yeah, it's 5 pages. It's actually not as bad as it looks. I think we can do it. Oh yeah, we can do this. We can still do this. Is it scored automatically or will I score it? Question's been asked. For the practice exam, it'll score itself. For the actual exam, I'd want to say almost all of it will score itself. There's a couple things like you guys have seen, like for example, the identities that we're just now doing, right? Those I actually need to see you guys write it out. There's no way to put in, there's no way to put in a.
Oh, hi. Yes, good morning. I just received an email from
Wait.
admissions saying that I didn't qualify for AB 540 because I didn't graduate from California high school. But the thing is that I actually graduated from a.
Oh, that was close. Okay, back to what I was saying. Almost all of it will be scoring itself. There's a couple things that I need to actually see to give you the points for. So I'll put the question in the actual exam and I'll see how you write it up. And based off of that one, I'll be able to give you a grade for it. So I would say nearly everything on the practice exam and exam 2 will grade itself. Somebody was going to ask a question. I heard
Yeah,
it.
so how is the test going to be working? So how are we going to be able to are we just going to hop on and are you going to send an online thing out that we're going to be doing? How's that going to work?
Yeah, so if you look at if you go ahead and go to your assignments in Canvas, there's already a Canvas there's already a practice exam 2 up.
Yeah, I see that one right there. Yeah.
So it's going to look exactly like that. Exactly like that, plus or minus a couple more problems. I'm not completely done with it, but for your guys' practice for now, it's done. Okay.
Perfect. So did we just hop on the upcoming assignments page for our homework and the test will pop up in there?
Right. So the test will pop up on Wednesday at 9:15. Exactly. And it will go on till what is it, 12 something, 12:30 or something.
Perfect.
Okay. And no, sorry. It'll pop up at, I'll do at 10, just so that everybody has time to ask me questions.
Perfect.
Yeah. So I'll do 10 from 10 to 12:30 for the test. And yeah. No, I'll do 10 to 1. Let's do 10 to 1. There's going to be an additional assignment for exam 2, where you have to take a picture of your write-ups for the exam for all of your questions.
Oh,
Okay.
so like our work basically.
Yeah, exactly.
So so just send the pictures of the work into the it's gonna be linked to the test, right?
Exactly. Yep.
Okay, perfect.
So for the practice test, like I said, you can take it as many times as you need to. If you get the 130 points for it, you get the 130 points for it. Got it?
He has to.
No.
I have a question on number 2.
On number 2. Number 2. Let's go to number 2. Okay. Which one?
The first one.
Uh-huh.
Would it just be for since wait, oh, would it just be you do, since it's cotangent squared, you just do 1 over sine over cosine, then times 1 over sine over cosine minus 1 over sine over cosine times 1 over sine over cosine, then times cosine, but then the since it's the subtracting, the 2 of the 1 over sine over cosine would cancel out, so then it would just be 1 over sine over cosine times 1 over sine over cosine times cosine.
You're doing it. Okay, so number 2, the first one, what you're doing is correct.
Mm-hmm.
Okay. But there's a much more elegant way of doing it.
Oh, could I have just like, so when it gives like the whole thing at the top, could I have just crossed out the cotangent squared minus cotangent squared, since it's subtracting, so they kind of cross cancel?
Not exactly. So how about this? What do both terms have in common?
Like the 2 cotangents?
Right. So both things, right, have cotangents in them, right?
Mm-hmm.
So you can factor out a cotangent.
Oh, so it would be cotangent to the 4th power?
So is my screen still sharing? Yep. Okay. So what I'm saying is this, right? You have 2 terms here. One here and the big one at the tail end, right?
Mm-hmm.
Cool.
Mm-hmm.
Both of them have cotangent in them.
Mm-hmm.
Right? So I can do this, right? Cotangent squared theta. What gets left behind?
Cotangent squared theta times cosine squared theta. I don't know.
So if you take out cotangent squared from here, well, come on. If you take cotangent squared from here, what gets left behind?
Just the cosine squared?
Nope.
The negative cotangent squared times cosine squared?
How about we start with that tail end? How about over here? So if we take cotangent from here, cotangent squared theta from there, what gets left behind?
Cotangent squared theta.
Nope. Try again.
I don't know.
A 1.
Not 1. From the green thing, from the tail bit. So I am pulling out cotangent squared. What gets left behind?
Oh, what is?
So how about we do it this way? We need to pull that out, right?
Mm-hmm.
Which means in here there's got to be something times something and then something times this to make this thing up here.
Oh, so something time. Wait, so we have to make the cosine squared that's at the end with the equals?
Exactly. So at the
Yeah.
very end, back here, right, there's going to be a cosine squared theta.
Yeah.
Does that make sense?
Mm-hmm.
That takes care of that one, right? But then what goes up front? And this is going to be a minus, right?
Oh, would it have to be like tangent? Not
No.
tangent. Sine.
No. Try again. These are tough.
Oh, is it now 1?
Yeah, it is 1.
Yeah, there you go.
Does that make sense?
No.
So look what happened, right? So if I do cotangent times 1,
Mm-hmm.
right, that gets me cotangent.
Mm-hmm.
And then cotangent squared times negative cosine squared, right,
Mm-hmm.
gets me cotangent squared cosine squared.
I think I kind of understand it. Like I understand it, but I don't know how to explain it. Like
It takes,
I
I
think
know
I
it's
understand.
yeah. This one's a difficult one. I gave you guys a hard one. And I know this one's hard. Just using the stuff that you guys are know for now, this one is hard. So there we go. So this is
Okay.
equal to 1 minus cosine squared of theta. But like I said, right, this is asking us to prove that it is equal to cosine squared.
Mm-hmm.
So we're not there yet. So I'll give you guys one more hint. I'll put it at the bottom. And that is your Pythagorean identity. Sine squared theta plus cosine squared of theta is equal to 1. You'll need this. Or you're going to need a variation of that to solve the rest.
Okay.
Yeah?
When it says reference angle, that means use the opposite, right?
You use the angle that is in quadrant 1, remember?
Okay. So it's always the one in angle 1?
Yep.
Okay.
Is cosine squared the same as no wait. Never mind.
Okay.
Okay, I got it. So is cotangent squared the same as cosine squared over sine squared?
Exactly.
Okay.
So that spits out. I'll go a little further on the thing that we have on the screen here. This is cosine squared theta over sine squared theta times 1 minus cosine squared theta. And it turns out I still haven't said too much.
Would you have to put the 1 minus cosine squared theta over 1 and then kind of like do it from there?
You can, or like I said, you can use this thing down here.
Would that using that down there be easier?
Yes.
Doesn't seem like it.
So how about this? So that thing is true, right? The thing in yellow is true no matter what, right? You can change it into other things.
Oh, so the same rule works for the other functions for like, I don't know which ones, but like, you get what I'm trying to say?
Kinda. So if you look at, if you look at the thing in yellow, right? 1 minus cosine squared is equal to what?
It's not sine, the thing at the bottom, isn't it?
Yeah, it is.
Oh, so the thing at the bottom is basically 1 minus cosine squared.
Is equal to what, though?
1 minus cosine squared.
Which is equal to what?
Oh, 1.
No.
Damn it.
So you grab the thing in yellow, right? And manipulate it so that you can get this thing.
Oh, so I almost had it for a second.
Well, what'd you have in mind?
I don't even know. Is this like one of those like clear like visions that are there for like half a second?
And then it's gone. Don't you hate those?
Yes, and usually I can remember them, but since it's math, it's like gone with the wind.
Yeah. So my last hint is to grab the bottom thing, the sine squared plus cosine squared is equal to 1, right? Manipulate it somehow so you can get 1 minus cosine squared. And that'll get you what you can substitute into that parentheses.
Oh, so we got to basically make sine equal 1 for in the bottom part so that it's the same as 1 minus cosine squared.
Exactly.
Now let's figure out how to do that.
Yeah. All right. We're cutting it a little tight. I do want to move into 5-4 since that's going to be what's on your exam. Don't want to take too much more time. Let me see what's here. Okay, yeah. So what we're going to mess with now is right triangle trigonometry. So as you guys sort of already realize, there's a bunch of triangles in trig. And rightly so, right? That's why we called it trigonometry, right? I want to cover really quick our good friend SOHCAHTOA, okay? So sine of some angle t, right? So depending on where t is where our definitions come from, right? The thing that's next to the angle, that's the adjacent. Opposite is opposite, and that long leg is always hypotenuse, right? So sine is opposite over hypotenuse. Cosine of some angle t is adjacent over hypotenuse. And then tangent of some angle t is opposite over adjacent, okay? So, again, using triangles, we can find all the values that we need for sine, cosine, tangent, all 6 of them, right? So, looking where our angle is here, right? It's right there. So, we need cosine. So, cosine of some angle alpha is opposite, sorry, cosine is adjacent, adjacent over hypotenuse. So that's going to be 15 over 17. And then tangent of some angle alpha is the opposite over the adjacent. Notice that we're calling opposites and adjacents relative to where our angle is. Okay, so the side that is opposite this angle alpha is the 8, and its adjacent is 15. So 8 over 15 there. We're done. Okay. Okay. I got 4 here for everybody to try. So what I want everybody to do is find the 6.
Could you go up? I'm so sorry.
Oh, go up.
I just need the last one. All right, I'm all set. You're all good now. Thank you so much.
Okay, cool. So I've got 4 more problems here. I'm going to break you guys up into your groups. I'm going to give you guys maybe 5 minutes to try them out, and we'll come back together. Cool?
For sure.
Okay. Not right now. Maybe about 4 o'clock. Maybe after that. Okay. Fine.
Hey, what's up, Professor Julio?
What's up, man? I think I just put you in a group.
Okay.
FYI.
Is the test this week?
The test is this week.
Did you already put up the practice test?
There is a practice test. It's online. So the idea behind it is it's going to grade itself. It's a completely online thing. If you go into your assignments, it should already show up. It should say practice exam 2.
Okay.
Yeah.
All right.
If you go in there, you have between today, tomorrow, and all of Wednesday until 11:59 p.m. to try to do it. I hope you try to do it before the actual test, which is this Wednesday.
Mm-hmm.
Right? But the test itself is almost identical to what you'll see on Wednesday.
Okay, for sure. Cool.
Okay, and you can use all your notes. You can use all my notes. You can use, because I can't keep you guys from using it, so that's why I'm just letting you guys go off with it.
Okay.
Got it?
Yeah.
Okay.
Are you making it hard?
Go look.
Okay.
I don't think it's hard, but then again, I'm the one teaching the class, so.
Oh, yeah.
I'm not making it. It's things that you have already seen. It's not anything you haven't seen before.
Okay, and it's
Yeah.
all of section 4 and all till 5.3, right? Something like that.
5.4. So it's going to be chapters 4 and 5.
Okay.
Yeah.
All right. Thanks, Julio.
Cool.
I'm probably gonna watch this video later, post it on YouTube.
Yeah, I'm going to put it up like right after class.
Okay, cool. Thanks, Professor.
Mm-hmm. Good. Yay? Nay?
No idea.
What do you mean?
It's like I don't. I think I did the right stuff, but I have no idea. We're basically going off of the other stuff we were doing, right? So like, and like the 1 over the sign stuff is still gonna be a thing. You just flip it, and
Exactly.
since there's no like square roots, we just do the flip and that's it.
And that's it.
Okay.
So what'd you guys get for your guys is what'd you guys get for tangent of alpha?
4 over 3.
Done.
Okay.
So what's cotangent?
Cotangent is 3 over 4.
Done.
Okay. Okay.
Yeah?
Yeah.
Okay. I'm gonna go bug other people.
Okay.
Let me see. Yay? Nay? Good? Bad?
I think I got it pretty easy.
Pretty easy, right? It's not bad.
Mm-hmm.
It looks intimidating, but it's not.
For the cosecant, secant, and the cotangent, we just gotta flip them, right? We don't have to do
Right.
much.
Yep, that's it.
Okay.
Okay. Let's see. Who else can I bug? Oh, that group, yeah. Yay? Nay? Thumbs up, thumbs down?
I'm still working on them right now. I think I'm confused a little bit. I think when we go over them, there might be clarification. Let me see here.
Well, how about this? What'd you guys get? What'd you guys get for tangent of alpha?
So, Of which one? Which one? I did all of them. I was doing all of them. Which one were we assigned?
Well, you guys were tasked with number 4.
Number 4. So
I
would Tana been 24 and let's see here. Would it be 24 over A?
Would it be 24 over 7?
Right, it'd be 24 over 7.
Oh yeah.
Nice.
Does it make sense, Hunter? Yeah.
So it was 24 over 7 for what reason?
So tangent is what over what?
Let me see my notes.
Yep. From the very tippy top of the chapter.
It's what the fuck is it? Where is it? Where is it?
Yuso Katoa.
I'm drawing blanks right now. I can't even think of it.
So let me share my screen with you guys.
Opposite adjacent.
Right. Opposite divided by adjacent. So let me share screen. So it's those 3, right? It's these 3. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent.
Perfect.
So for an angle T, right? So in this case, my angle is right there. For tangent, I need opposite divided by adjacent, right?
Yes. And that's exactly what 24 over A is, isn't it? Or 24 over 7 is.
Right, exactly. Got it?
Yes.
Boom. Okay, I'm going to call you guys back because we have maybe like a bit more than 10 minutes in class. I want to cover these. How we doing? So, do you guys know that? How many of you guys have actually watched like what is it? Narcos. The one with the OG with Pablo Escobar. Yeah, you guys know that meme that's going around of Pablo Escobar just like walking in and around his mansions all by himself and just like staring at stuff. I just had one of those moments. Like I literally, like I went into my bedroom, I sat down for a little bit, looked at stuff, went outside, looked at the sky, looked at some rocks on the ground, then came back inside, saw you guys didn't ask any questions, and went back outside. Totally a Pablo Escobar moment. All right. I think everybody's back. I'm going to try out a couple of these just so you guys get some feedback on what you did. I'm going to try 2 of them. And I'm not going to completely do them. I'm going to do 1 and 3. Just so you guys get a hang of what the heck's going on, right? So sine of t, right? So my alpha, my angle, I should use the actual lettering that's given. So my angle is there, right? So my opposite is 4. My adjacent is 3. No, sorry. Over hypotenuse. 5. Cosine of alpha is adjacent over hypotenuse. So that's going to be my 3 over 5. Right? And then my tangent of alpha is the opposite over adjacent, which is 4 over 3. So those are the big ones, because the rest we know is the flips of these 3 right here. So cosecant alpha is the flip of this one. So it's going to be 5 over 4. Secant of alpha is the flip of the next one down, 5 over 3. And then tangent of alpha is going to be the flip of, cotangent, C-O-T, is the flip of tangent, which is 3 over 4. And we're done. We have all 6 already. So notice if we use our triangles, some of this stuff is actually a little easier, okay? I'm actually going to skip that one. I want to move on because it's going to be, I think everybody got this. Co-identity and complementary stuff. I'm going to skip this. This will not be on the test. What I do want to cover is this next thing down here, though. This is the reason why trigonometry is so important, okay? And it's because we are going to, so as it stands, right? Suppose we didn't have this angle here, okay? Suppose we didn't have that angle there. There's no way for us to find any of the other sides, A or C, right? But since we have an angle, we can find the rest of the sides. So for example, if we need to find A or C, right? Let's go ahead and let's say we want to find A. Okay, so then that means sine of 30 degrees is equal to, tangent. Tangent of 30 degrees is opposite over adjacent. So 7 divided by A. Okay? We do our little voodoo math and we get A is equal to 7 divided by tangent of 30 degrees. Right? So now we know what tangent of 30 degrees is. If we look at our unit circle, that's sine over cosine. So that's sine is 1/2 divided by root 3 over 2. And if we do this right, is root 3 divided by 3.
And on that, would you just would you multiply both of those together or divide them to get that?
So they're in a division, right? So let me do that really quick. So you have 1/2 divided by root 3 over 2, right? Which means you're dividing fractions, which means you can flip the second and make it into a multiplication. You remember that?
Yes. So it'd be
So
2 over 3.
Root 3, but yes. 2 divided by root 3. There's a 2 on top, 2 on bottom. 1 over root 3, right? You can multiply root 3 on the bottom and on the top. Root 3 over 3, 3, 3, 3, 3. Okay? We good, Hunter?
Yeah, I'm good.
Okay. So why the heck did I do this? And actually, let me move this over a little bit so I don't encroach on some more space, which I might need. Oh. I put square root of 3, square root of 3. There we go. Okay. The reason why I did this is because now I can use it in A. So then A is equal to 7 divided by square root of 3 over 3, which is equivalent to 21 over root 3, which is 21. If you do it all right, let me see. 7. Yeah. 7 square root 3. Do I need to show the voodoo math there? I might as well just should. I just should do it, huh?
If possible, yeah.
Yeah. Okay. So we have this going on, right? So A is equal to 7 divided by root 3 divided by 3, right? Is the same thing as 7 over 1 divided by root 3 over 3. Okay. I can do 7 over 1 times, I can flip the second one, 3 over root 3. Here's where I get my 21 divided by the square root of 3. I don't like square roots on the bottom. Nobody does. So to get rid of the square root on the bottom, I'm going to multiply it by a square root on top and bottom. These two right here combine to just 3, right? And then the other one on top. So 21 square root 3 divided by 3. Now, 21 reduces by 3.
7.
7. And that's where I get my 7 square root 3. So that is why this stuff is really, really useful. We now know that this is true. My A is 7 square root 3. Okay. Let's go ahead and try to find C. So C, in order to find C, I'm going to need a hypotenuse. I'm going to use this opposite, right? So I have an opposite, I have a hypotenuse, that's sine. So I'm going to do sine of 30 degrees is equal to my opposite, so what letter was that? Oh, 7 divided by C. This implies C is equal to 7 divided by the sine of 30 degrees. Again, we can use our unit circle. 7 divided by sine of 30. Look at that, that's 1/2. So we have this going on again. 7 over 1 divided by 1/2. 7 over 1 times 2 over 1. So I can turn my division into a multiplication by flipping the second. 14. So we've done a bunch of stuff here, right? So this one ended up being very difficult. Just tedious, actually, more than anything. So A is equal to the 7 over tan 30, and all of that reduced down to 7 root 3. And then same thing here, C reduced down to 14. So then tells us this is true. And that's the point behind trigonometry and the six trig functions. They are, remember the Etch-a-Sketch idea? They're a ratio of how far up and how far over you have to go relative to a hypotenuse, relative to a really, really long length, right? And with that, I went 2 minutes over. So I still am going to include this section. I haven't completely finished yet, but we are there. I swear to you, we are there. So I think I'm going to take maybe the first 30 minutes of exam day, maybe less, first 20 minutes of exam day. I wish I was high on Alpati. I'm going to use the first 20 minutes of exam day to answer questions. Cover this all first, just so you guys get a little bit of exposure for it. Cover this stuff and answer questions, and tail end of the class time we'll do the exam. Okay. Besides that, I am done. Unless you guys have questions, ask me. I'm on for the next couple, maybe what, 15 minutes if you need me. Hunter?
Ooh. Actually, yeah. I had a question about an older problem, actually, from 5.1.
5.1. Let's go there.
It's actually on, let's see here. It's on area of sector. So the problem is a sector of a circle has a central angle of 135 degrees. Find the area of the sector if the radius of the circle is 16 centimeters. So the question was basically, when you do this, you'd find
This is from your homework, right?
Yes, correct. Actually, yeah.
Okay, so it's not from the packet itself, right?
It's not from the packet itself. It's on it's on 5.1 angles, on the actual homework. I was just asking. So for 135 degrees, you first find what the radius or the radians are, right? Which would be if 135 degrees was put as a radian, it would be 3 pi over 4, I believe.
Yep.
So would you then do 1/2 3 pi over 4 times 16 squared? If it was 16, and then you would do so for the math there. How would you just multiply all of them together and then get your answer?
Yep.
So actually, I think I have this. This isn't too bad. So it seems like chapter 5.1 was very basic.
And chapter 5.1 was just to get you guys sort of comfortable with going back and forth.
Yeah.
Between angles and radians and angles, and how they're used and how they're sort of similar and how they're equal. Yeah, that's it.
For sure. Awesome. So on the test, when it comes time,
yeah,
there's portions from a lot from chapter 4 and 5 in there, right? It's not just all chapter 5, all chapter 4. It's a good balance.
It's a good balance, yeah.
Okay, perfect.
Got it?
Yes.
Okay.
I got the answer right. Perfect.
Boom. Okay, I'll see you guys all on Wednesday if you guys are heading out. Like I said, I'll be on for maybe another 5-10 minutes if you guys have questions for me. But class is done. You are dismissed. Go enjoy the beautiful day. even if you guys are locked
Cooped up
in,
inside,
like,
yeah.
even though you guys are cooped inside like Pablo Escobar.
No problem. Have a good one, okay?
Yep. Yeah, you too, man.
Yeah. Can I have a quick question?
Is that Mohammed?
Yeah.
Okay, what's up?
Yeah. How many questions on the actual exam?
I think the practice exam that I put up, I think has 12.
Yeah, it shows like 13 questions.
13 questions. So I think the actual test, I think I might add 2 more because I don't think I've covered 5-4 yet completely, entirely. But it's going to be probably going to be around, I don't think I'll pass 15 questions.
Okay.
Does that make sense?
Yeah, yeah. So for the practice exam, if I start it right now, and in case I close it, then I can try it again?
Yes.
Okay.
Will it continue with the same quiz? Let me, you just gave me you gave me something that I need to check. So I want you guys to come back and try the same problem. I don't want it to, how did I say it? Like if you exit the assignment, if you exit the quiz and then come back to it later, I want you guys to still look at the same quiz. Does that make sense?
Yeah.
Or sorry, if you go back to exam 2 later, I want you to look at the same exam, not, have it start a new one for you.
Yeah, I mean, like, for example, I solved 2 or 3 questions and quit it for now. And after like maybe 2 hours later, I started back. So it will start it again, or just it will save the.
That's a good question. Let me. I'm looking at it now.
Okay.
Allow. So it says allow multiple attempts. Quiz score to keep highest. Allow attempts. Let students see the response. Quiz response. And student feedback. Okay. Okay. I wonder whose kid was that. That kid needs a nap. How about we do this? Don't block questions after answering. Okay. I think what I did makes it work. So I don't think I can, let me put it this way. I don't think I can, as an entire quiz, give you that option. It doesn't say it lets me allow that, but I can do it for each question. Does that make sense? So once you get one question right on the practice exam, right? It won't change that question. It'll keep that question the same.
Okay.
I think. Try it out.
I mean, like once one question is solved, so it will save it for the next attempt.
Right, exactly. So it won't make you do that question again.
Okay, thank you. That's good.
Okay.
Yeah. And the actual exam will be started on Wednesday. And right now I couldn't find any link for that. I think it will be added like right after, yeah?
Yeah, I haven't put it up yet.
Okay. Okay.
But
good.
I will.
Yeah.
On Wednesday.
Okay. Thank you.
Okay. Uh-huh.
Yeah. Okay, have a nice day.
All right, you too, man.
Thank you.
I'm looking at my sumo bun. It's getting bigger and bigger every day. It's keeping hair out of my face, though. All right, Dana, Mohammed. Dana. I'll be in my office hours, I think later on today, 2 to 3. And then from 1:15 to 2, I got lab hours. So you can find me in the lab, the virtual lab. Yeah. Good luck with the crackhead stealing your internet. Hopefully he stops. All right, besides that, man, I'll see you Wednesday, early Wednesday morning. Okay, later.